Okay, today we're going to graph tangent and cotangent functions. Remember that tangent is a little different than your sine and cosine. You know that the period for a tangent function is just pi. Typically, we graph tangent from 0 to pi. But to make it the best type of a graph, we're not going to graph tangent from 0 to pi. You're actually going to graph tangent. Tangent's defined on the unit circle really from what we call negative pi over 2 down here to pi over 2 up here. So this is where we call tangent being defined. Okay? Now, when you graph tangent, we have to make sure that we graph it between its two asymptotes. Make sure you make this correction on your paper. This should say two asymptotes. Tangent, again, does not have an amplitude, so you don't have to worry about the amplitude when you come up with the equations when you have to find them. But right now, we're going to already be given our equations. So the first thing we're going to do with tangent function is make a table. X and tangent x, or x and y. Okay? So the increments we're going to go is from negative pi over 2 to pi over 2. So if you think about the values you need to include from negative pi over 2 to pi over 2, there has to be 5 values. So back over on the unit circle here, think of your 5 values that you're going to include. That's negative pi over 4. Yes, we know that really is 7 pi over 4 in the unit circle, but we'll call that negative pi over 4. This is 0, and then this is your pi over 4. So those are our values we'll have for x. So negative pi over 4, 0, and pi over 4. Okay? So starting with negative pi over 2. What's the tangent? Well, remember, tangent is always equal to the sine divided by cosine, or y divided by x. So at negative pi over 2, if this ordered pair is 0, negative 1, that's negative 1 divided by 0. That's undefined. Okay? At negative pi over 4, the value here are that radical 2 over 2, comma negative radical 2 over 2. When you take y over x, that just makes that negative 1. And then tangent of 0, which is 1, 0, that is just 0, because 0 over 1 is 0. And then the tangent of pi over 4 is positive radical 2 over 2, comma radical 2 over 2, and that makes it 1. And then tangent of pi over 2 is 0, 1, which again, 1 divided by 0 is undefined. So you will always graph tangent between its asymptotes. So now go to the graph. This is negative pi over 2. This is positive pi over 2. This is where you draw your asymptotes. Right here. Then label negative pi over 4, positive pi over 4, and 0. At negative pi over 4, you're down at negative 1. At 0, you're at the origin. At pi over 4, you're up here at positive 1. This is going to look like the cubic function that we did in Algebra 2, and it will have this inflection point right here at the origin. Okay, so that's how all tangent functions look. When you have to do a transformation, I would just stick with tables right now and just do your transformations from your tables. Okay, so when you graph and state asymptotes, your asymptotes are on your graph right here, and what you can say is that tangent, the period, is pi. The asymptotes are really every pi over 2 value plus n pi. That means that every time you repeat and you go a pi value from pi over 2, you'll repeat an asymptote. So that's how you state asymptotes. Don't worry about this too much because we'll get to that on Monday. Okay. Cotangent. Well, cotangent is just the reciprocal of tangent. So when you think of cotangent, you would think of when is it defined on the unit circle. So we're looking for the cotangent of x. So if I kind of draw my little mini unit circle over here, well, cotangent, if it's the reciprocal of tangent, well, you'd ask yourself, well, what's the reciprocal of undefined? That's 0. The reciprocal of negative 1, that's 1. The reciprocal of 0, that's undefined, and that's 1, and that's 0. That's not going to give you a good graph if you use these same values. So you want to use values that will start with an undefined value of cotangent. Well, think about the unit circle. Cotangent is best to go from 0 to pi, because if you think about what's the reciprocal of 0, the reciprocal of 0 is undefined. Okay? And then if you go pi over 4, which is the next value, the reciprocal of 1 is just 1. If you go to pi over 2, where tangent is undefined, the reciprocal of undefined is actually 0. And then over here is 3 pi over 4, and the reciprocal of 3 pi over 4, which the value of that is -1, is -1. And then when you're back at pi, the reciprocal of 0 for tangent at pi is undefined. So it will look similar, but now your graph is a little bit different. So go over to your graph, and now you're going to have an asymptote that's actually on the y-axis, and an asymptote out here at pi. You've got pi over 2, pi over 4, 3 pi over 4. And you have a maximum value of 1, minimum value over here at -1. And so you've got at 0 it's undefined, at pi over 4 you're up at 1, pi over 2 you're at 0, 3 pi over 4 you're at -1. Same type of graph, it just looks like it's been reflected. And that is what the cotangent graph looks like. Again, the period for cotangent is also pi, and the asymptote stating it for cotangent would be every pi, you have an asymptote plus n pi again. So you'd have an asymptote at pi, at 2 pi, 3 pi, 4 pi. That's what that means. You are to complete the rest of this packet. Make sure you have tables today. I will be looking for tables with your transformations, and that's all you have to do, and please be respectful to your substitute. Thank you.